In this video, we'll focus on chapter 7, which will be covered in two parts. The first part is chemical reaction, the second part is chemical quantities. So, begin with understanding what is a chemical change or is a chemical reaction. A chemical reaction is essentially defined as a reaction when a substance is converted into another substance with different formula and different properties. What is that essentially means is that during a chemical reaction, a chemical substance changes its identity. The atoms basically change the atoms basically change in the substance. The atoms are swapped between different substances. That is called a chemical change or a chemical reaction. The new substances that are formed have completely different properties than the previous substance. Some of the signs that will essentially tell you if or give you an indication if a reaction is a chemical reaction or a chemical change or not is formation of bubbles. For instance, if you want, you can try this experiment at home. If you have some baking soda and you add some lemon juice to that, or let's say vinegar into that is going to produce a lot of gas, and all the gas that is produced will be released in form of bubbles. So you'll see that baking soda will essentially start bubbling as soon as you add lemon juice or vinegar on top of it. Baking soda here is a base, and lemon juice that is being added or the vinegar is an acid. So during this reaction, a lot of CO2 is produced, and that CO2 is released in form of gas, which causes the reaction to look like bubbles. And that is an indication of a chemical reaction. Here, the substance, which was sodium bicarbonate, and the acid from vinegar is reacting to produce something completely different, which is CO2. So here the atoms are basically changing their positions. They are changing their identity. The atom stays the same, which means carbon stays as carbon, but essentially initially the carbon was present in acetic acid, but now that carbon has turned into CO2. So basically atoms are exchanged between different substances. Other type of indication which would tell you if a reaction is chemical or not would be a change in color during a reaction. For instance, we know that silver eventually over time turns a little darker. It turns a little greenish or blackish in color, and that is called tarnishing of silver. That is a chemical change. What is happening there? Silver, which is very shiny metal, is reacting with sulfur and is changing into silver sulfide, and this new substance that is formed is green in color or blackish in color, and that's why it covers the shiny silver material with its blackish or greenish product. So this is called a chemical change. Usually whenever during a reaction a color change is happening, that is an indication that it is a chemical change. Another example would be when iron rust. Whenever iron rust, it forms something brown product. So iron is Fe, which is again a solid metal which is very shiny. When it comes in contact with oxygen, which is a gas in air, it turns into iron 3 oxide, and this solid is brown in color, and this is shiny metal. So basically what is happening here, this shiny metal is converting into something brown. So this is an indication of the chemical property. The property of the substance look completely different. Initially it was looking shiny, and now it is looking like brown in color. So this is telling you that the identity of the compound has changed. It is no longer iron and oxygen, it has turned into iron oxide. So this is an example of a chemical reaction as well. Other indicator is production of a solid or precipitate. You would see some of these examples later in the chapter. So essentially what this means, precipitate is any solid that is produced during a reaction. So let's say you might have seen some reactions online in some YouTube videos where two clear solutions or transparent solutions are mixed together and it produces something solid, something completely different. That solid that is produced is called a precipitate. That means that that solid is no longer soluble in water. And if you see something like that, that is also an indication of a chemical reaction. The next is production of heat or absorption of heat. So for instance, when we burn gas cylinders, right, during barbecues or even our gas stove. So on our gas stoves, the normal gas that is provided to us is methane. Methane reacts with oxygen in air to produce carbon dioxide and water, and that basically produces flame. Happening in that reaction, we are supplying a different type of gas, and after burning it is converting into something chemically very different. So that is an example of a chemical reaction as well. So here is the reaction that we saw before, where methane gas is burns in oxygen to produce carbon dioxide. So this is methane, CH4 is burning in oxygen to produce carbon dioxide and water, and this produces some heat energy which is used for cooking. And what you see right here is called a chemical equation. So a chemical reaction in chemistry is usually represented by a chemical equation. This chemical equation tells you what are the reactants and what are the products, how many reactants are used and how many products are produced. So in a chemical reaction, you will always see an arrow which tells you the direction of the reaction. Here the reactants are always written on the left side of the arrow and products are written on the right side of the arrow. Reactants basically are being converted into products. That's why you see arrow going from left to right. Now what's important here, in a chemical reaction you will always write each reactant that is involved, the chemical formula for each reactant. And what does this chemical formula tell you? Each chemical formula gives you information about the chemical reaction. For instance, here if we look at CH4 methane, that is telling me that each methane molecule consists of 1 atom of carbon and 4 atoms of hydrogen. The subscript that you see in each of the molecule or chemical formula is telling you how many atoms of that particular element is present in that compound. These subscripts are always fixed. If you change the subscript, basically you're changing the chemical identity of the compound, and that you might have seen already. You probably have seen the video before, which is about molecular compound and ionic compound. How do we get their formulas? If you haven't, you should go and watch that video. In that way you would know that you cannot change the subscript of a molecule, the subscript of an atom in a compound, because that would modify the type of compound we are talking about. It modifies the chemical identity of the compound. So here what we are seeing in this particular reaction, you can see that there are two reactants. One is CH4, one is O2, is changing to CO2 and water. So that is what you write in a chemical equation. Now after you have written a chemical equation, there are a couple more important things that we have to make sure that we include in a chemical reaction. One is the phases of the states of all the matter that is present. Phase means what is the state that they are present in, meaning they are solid, liquid or gas. So most commonly seen phases that you'll see in reaction, either something is solid, so it's written as S in parentheses, liquids are written as L in parentheses, gases are written as G in parentheses, and another commonly used state is AQ in parentheses. AQ basically stands for aqueous. Aqueous means whenever something is dissolved in water, that stands for aqueous solution. For instance, if I say NaCl, NaCl is salt, table salt that we eat, that we consume. Table salt is usually solid, but if you will take a spoon of that salt and dissolve it in a cup of water, when it is dissolved, it is called an aqueous solution. So that solution is called a salt solution, which is in water. So aqueous basically means it's a solution in water. Now the last important thing whenever we write a reaction, chemical reaction, is to balance that chemical reaction. What does balancing mean? Balancing essentially means that the number of atoms on the reactant side of our equation must be same or equal to the number of atoms on the product side of a reaction. Okay, so for instance, if we look at this particular reaction right here, let me rewrite that. That is CH4 is reacting with O2 to produce CO2 and water. Here everything is gas, so we'll include their phase in parentheses as gas. Now let's see if this reaction is balanced or not. How can you identify? You will start working with one atom at a time. Look at one atom and see if that is balanced on the reactant side and the product side. If it is not balanced, then we will change the number in front of that molecule. Remember, whenever we are trying to balance a reaction, you can never change the subscript of an atom. So I cannot add carbons here or by changing the number 4 here. Only way I can change the number of atoms is by adding a number in the front of the compound. This, if I end up adding a number in the front, that number is called as coefficient. Okay, coefficient essentially tells you what is the number of molecules of that compound that are being used in that particular reaction. Okay, for instance, let's start with the first one. The first will pick the first atom, which is carbon. How many carbon atoms do you see in the here? If there is no coefficient written in front, we'll assume it is 1. And what is the number of atoms? The number of atoms is always coefficient times the subscript. Okay, so in this case the coefficient is not written, so I'll assume it is 1. The subscript is not written, so I'll assume it is 1, which means how many carbon atoms? 1 carbon atom. How many carbon atom do I see right here in the product side? 1 carbon atom again. So carbon is balanced. Next we move to hydrogen atoms. So how many hydrogen atoms do we see in reactant side? 1 times 4, which is 4. How many hydrogen atoms do we see in product side? It is 1 times 2, which is 2. Now what is important when you're balancing a chemical reaction? If you see that the number of atoms is not balanced, you can only balance it by adding the number of atoms. You can never take the number of atoms out. So what that means is, if I need to balance this reaction, I have to make both the sides equal to 4 hydrogen atoms. I cannot take and reduce this for 2. Only thing that I can do is I can only increase this number 2 of hydrogen atoms to 4. And how can I do that? Only by changing the coefficient. So if this is 2, what should I multiply this subscript by so that my number of atoms become 4? So my number of atoms I'm looking for is 4. Coefficient is what I multiply it by. So what should be my coefficients? And my subscript is 2 here, right? H2O. So it is 2. What should I multiply this 2 by? So my final number becomes 4, 2. So I'll put a number 2 right here. Now what is the final number of my hydrogen atoms? I'll cancel this out. I'll recount it. It would be coefficient times subscript. So 2 times 2, which is 4. So number of hydrogen atom is balanced. Now we move to the last one, which is oxygen. How many oxygen atoms are present on the reactant side? 2. How many oxygen atoms are present on the product side? Here I see oxygen is present in both the atoms. So we'll count first in each one of them. In CO2 I see 2, and in water, now since I've added this 2 in the front of it, it is 2 times 1, which is also 2. So total number of oxygen atom is 2 plus 2, which is 4. Again, if I want to make it equal on both the sides, I have to change this 2 to 4. Only way I can do that is by adding a 2 in front, which would change the number to 2 times 2, which is 4. Now oxygen atom is also balanced. So what is the final reaction? The final reaction would be 1 CH4 molecule will react with 2 oxygen. So you can see it written right here. 1 CH4 will react with 2 oxygen atoms or molecules to produce 1 CO2 and 2 water. To produce 1 CO2 and 2 water. So that is our balanced chemical reaction. Okay. What this means is that every 1 molecule of CH4 will use up 2 molecules of oxygen and will produce 1 molecule of CO2 and 2 molecules of water. This coefficient essentially tells you number of molecules being reacted or being produced. What is important here to remember is that the coefficients are always supposed to be whole numbers. The coefficients are the numbers that go in front of the molecules. They should always be whole numbers. They can never be fractions. Okay. So now let's try a couple other reactions, balancing them. So for instance, if I say production of water, hydrogen gas reacts with oxygen gas to produce water. This requires a lot of energy. It cannot just happen by itself. So if we were to balance this reaction, we start by counting 1 atom at a time. So how many hydrogen atoms do I see in my reactant side? I see 2. How many hydrogen atoms do we have in products? Also 2. Perfect, that is balanced. Now we move to oxygen. How many oxygen atoms do we have on reactant side? 2. How many oxygen atoms on the product side? 1. So now oxygen atom is something that I will have to balance. Since my product has less oxygen, I will have to add more oxygen to that. The only way I can make this 2 is by adding it as a coefficient. So 2 times 1 will give me 2. Now number of oxygen atoms is balanced. Oxygen atom here is also 2 and here is also 2. But now we have changed the number of hydrogen atoms. So whenever you add an exponent and it also consists of some other atom in that compound, you have to go back and balance the other element. So now we'll have to rebalance this hydrogen atoms. So how many hydrogen atoms? You can basically cancel these numbers out that you saw before and redo this. So let's redo this. How many hydrogen atoms do I have on the reactant side? 2. How many hydrogen atoms do I have on the product side now? 2 times 2, which is 4. So now I'll have to add an exponent 2 here, so that 2 times 2 here becomes 4, and my number of hydrogen atom is also balanced. So the final chemical reaction would consist of 2 molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water. So these exponents are very important. Okay, moving on, let's say if we are balancing this particular reaction, how would the question look like? The question might look something like this in words. Don't look at the steps that are written for now, just look at the compound. So let's say if we are working with this, aluminum plus sulfur produces aluminum sulfide. So if we are looking at this reaction, we have to first come up with the chemical formulas for each of them. What is aluminum? Aluminum is Al. It's a metal, so it will be solid. Plus sulfur produces aluminum, so which means both of these are our reactant. Aluminum and sulfur. Sulfur is also found as a solid. It produces what? It produces aluminum sulfide. Now aluminum sulfide, first thing we have to do is come up with the formula for this compound. If you have already seen the previous video, you would know aluminum sulfide is ionic compound. Aluminum is metal, sulfide is non-metal. And how do we come up with the chemical formula for this? Aluminum will form a metal ion. It belongs to group number 3, so it is Al plus 3. Sulfide is a non-metal that belongs to group number 6, which would be 8 minus 6, so it will form 2 minus anion. These numbers of charges will cross over and the actual formula will be Al2S3. So the product that is being produced is Al2S3. This is also a solid. I do not expect you to remember which one's solid, which one's liquid, except the most logical ones. For instance, aluminum is solid. You should know that. Aluminum sulfide is something new to you guys. So if I give you something new which is not that common, I will probably tell you what is the face of that compound. But if it is something that is commonly used in chemistry or commonly used in household, then those will not be provided to you. Okay, anyways, if this is now our reaction, we need to now balance it out to figure out what is the actual number of molecules for each of the atoms. So let's start balancing it. How many aluminum do we see here? I see 1. How many aluminum on the product side? I see 2, which means I will have to use a coefficient of 2 here to make this number of atoms also 2 on this side and 2 on the other side. So aluminum is balanced. Next we balance sulfur. How many sulfur atoms on reactant side? 1. How many sulfur on product side? 3. To balance it, I need to make it 3 on both the sides, and in order to do that, I'll have to multiply the reactant side by a coefficient of 3. So the final answer here would be 2 aluminum molecules or atoms here will react with 3 sulfur atoms to produce 1 aluminum sulfide. So this would be a final balanced chemical reaction. There are some more examples here for you guys to try. This reaction is chemically balanced already, but you guys can try and balance it out by yourself. The question is asking, state the number of atoms of each of the element on the reactant side and the product side for each of the following balanced equations. So remember, these equations are already balanced. The question is asking how many atoms of each do we have. So in here, phosphorus, how many atoms do you see? 4. How many atoms of bromine do we have here? Again, coefficient times the subscript gives you 6 times 2, which is 12. Here in PBr3, how many atoms of phosphorus? This would be 4. Coefficient is 4 times the exponent. Oh, sorry, the subscript, which is here 1. If it's not written, it is 1. So phosphorus in product is also 4 times 1, which is 4, and bromine is 4 times the subscript, which is 3. So 4 times 3 is 12. So essentially all of them you can see are balanced. 4 and 4, 12 and 12. But let's see if we were to balance this reaction. The question would look like P4 plus Br2 is changing into PBr3. So how do we balance it? I see that I have number of phosphorus atom is 4, and here I only see 1. To balance it out, I need to multiply this by 4. Now the number of atoms of phosphorus is 4 times 1, which is 4. How about bromine? The number of atom here is 2. The number of atom on the product side is, now we have added 4, so that will be count for it. Okay, so 4 times 3 will give you 12 atoms. And how many do I have on this side? 2, which means I need to make this number equal to 12 as well. What should I multiply 2 by to get 12? You'd multiply it by 6. So this would be now 6 times 2, which is 12. So everything is balanced. So this would be your final chemical balance reaction, as you can see up here. Same thing you'll do with this. Number of aluminum atom here is 2. Number of iron is 2. Number of oxygen is 3. Number of iron here is 2. Number of aluminum here is 2. Number of oxygen here is 3. And you can see all of them are balanced. 2 aluminum, 2 aluminum, 2 iron, 2 iron, 3 oxygen, 3 oxygen, right? Okay, moving on, let's balance this chemical reaction. How can we balance it? What do we see here? There is oxygen reacting with C2H6 to produce CO2 and water. So here, how many? We'll start with let's start with one of the atoms. What you see here is oxygen. Oxygen on the reactant site is present here, whereas oxygen in the product is present in 2 compounds. So my suggestion to you guys would always be, whenever you see a reactant and product reaction, always leave the atom which is common to different reactants and products, leave it for the end, which means, for instance, right here, oxygen, I see that it is present in both the products. So I'm going to leave oxygen for the end. I'll work with the atom which is only present in one of the compounds in the beginning. Okay, always begin with an atom which is only present in one of the compounds in reactant and one compound in the product. If it is present in more than one, then use it at the end. Keep it for the end. So I'll keep oxygen for the end. I'll start with carbon. How many carbon atoms do we see here? 2. How many carbon on the product side? 1. Which means I'll multiply this by 2. And that would make this 2 times 1, which is 2. Next we come to hydrogen. How many hydrogen do we see here? 6. How many hydrogen on the product side? I only see 2 right now. I have to increase this 2 to 6. What should I multiply 2 by to make it 6? I multiply it by 3. So my exponent here is 3. Now the number of hydrogen atom is 3 times 2, which is 6. So hydrogen atom is balanced. Now we come to oxygen. How many oxygen do we see on product? Oh, sorry, reactant side? 2. How many on the product? I see 2 times 2, which is 4 oxygen atoms in carbon dioxide, and 3 times 1 in water, which is 3. So total is 7. Remember, to whatever coefficient you're adding, make sure you include that in each of the atom now. Okay, so it is 2 times 2. That's why this is 4. Now the number of oxygen atoms I see here is 7, and number of oxygen atom I see on the other side is 2. Now this situation is tricky because it is odd and even. Now how do I multiply this oxygen 2 by a number so that I can get it equal to 7? If you think of this, what should be the final number I want is 7. Number of atoms, right? Number of atoms, remember, was coefficient times the subscript. So in this case, 7 is equal to coefficient, which is, what should be the coefficient so that my subscript here is 2. So what should I multiply this by, to 2 by, to get 7? This number would essentially be 7 by 2, right? So if I multiply by this fraction, which is 7 over 2, then I would get number of atoms now will be 7 over 2 times 2, which is 7, right? Let me rewrite that this is 7 over 2. So if we are doing this, then we are okay. But remember, we mentioned that we never have the coefficients can only be whole numbers. They are never fraction, never decimals. So how can I get rid of this fraction now? The best way is if I multiply the whole reaction by 2, I can get rid of this fraction. So whenever you see something like this, where one of the compounds, only one of the compounds in its natural state is giving you odd and even numbers, use a fraction. Use a fraction in the beginning and then convert it into a whole number. So if this is 7 over 2, I can multiply it by 2 and that would convert this into whole number. But you cannot simply multiply one of the reactants or one of the products. You have to multiply the whole reaction. So now your final reaction would be 7 over 2 times 2 will give you 7 oxygen molecules, plus, since this is 1 times 2 will give you 2 C2H6 gas is converted to, it was 2 initially, now multiply by 2 will give you 4 CO2 gas molecules, and 3, it was initially 3 times 2 will give you 6 water molecules. So this would be your finally balanced reaction. Another important thing when you're working with coefficients is that the coefficient should be in the lowest ratio possible. So in this case, you can see the ratio is 7:2:4:6, which is the smallest ratio possible. So that would be your final answer. Okay. I need to. So here are some more examples. Let's start with the first one. What we see here, iron oxide is reacting with carbon to produce iron and carbon dioxide. So to balance it, we start with one atom at a time. How many iron atoms? 2. How many iron atoms on product? 1. To balance this, I will have to increase the number of iron atoms in product. Only way to increase it by adding an exponent, coefficient, which would be 2. So 2 times 1, which is the subscript, is now 2. So total number of iron atom is balanced. Now we move to oxygen. How many atoms of oxygen here? 3. How many atoms of oxygen on CO2? 2. Now again, to balance this out, since it's an odd and even issue, the only way we can balance here is by making this 2 and making this 3. Now the number of oxygen atom here is 3 times 2, which is 6. Number of oxygen atom here is 3 times 2, which is also 6. But the problem now that we have is we also change the number of iron here. So to balance the iron, I'll have to fix this now. 2 times 2 is 4. So here what I have is again 1. To make it balance, I need to replace. So in this case, we'll have to modify the number of iron to 4. So instead of 2, we'll be using number 4 here. That would make it 4 times 1, which is 4. So iron is also balanced. Now we move to carbon. The number of carbon atoms here is 1. Number of carbon on the product side is now 3 times 1, which is 3. So to balance it, I need a 3 right here. So my exponents that I see are 2, 3, 4, 3. 2, 3, 4, 3 is B. So that's our answer. Moving to the next one, I see aluminum with iron oxide changes to iron and aluminum oxide. Number of aluminum here is 1. Aluminum on the other side is 2. Number of aluminum has to be changed to 2 on both sides, so I'll add a 2 right here. Next we move to iron. Number of iron is 1. Number of iron is 1. So iron is okay. Moving to oxygen. Number of oxygen here is 1. Number of oxygen here is 3. To balance it out, I need a 3 in front of FeO. But that changes the number of iron. The oxygen here is 3 now and 3, which is balanced. But the number of iron has to be changed. Here now the number of iron is 3. So I have to modify this and change it from 1 to 3. To do that, I need an exponent. So the coefficients are 2, 3, 3, 1. 2, 3, 3, 1 is A. Moving on to question number 3, which is aluminum. So again, I start from aluminum is 1. Aluminum on the other side is 2. To balance it, I need a 2 right here. So now it is 2 times 1, which is finally 2. Next, we move to H2SO4, which is sulfuric acid. It's changing to sulfate and hydrogen. So basically, the sulfate here stays together. Hydrogen here I have is 2. Hydrogen here I have is also 2. So we are good on that. Now sulfate, remember, don't break it, keep it all together. The number of sulfate here, you see there's no number, so it is 1. So this is 1. Here I see that sulfate is 3. To make it equal, we need a sulfate. We need to add a 3 here. Don't add 3 on the bottom. We only add coefficient. So this is 3. This is also sulfate is now 3 on both these sides. But by adding this 3, we have changed the number of hydrogen atoms. So I'll have to rebalance hydrogen. How many hydrogen do we have now? 3 times 2 is 6. How many hydrogen on the product is still 2. To make this 2 equal to 6, I need to multiply it by number of 3. So now 3 times 2 will give you 6 hydrogen atoms. So this is also 6, this is also 6. So now everything is balanced. And the exponents we see is 2, 3, 1, 3, which is B. Okay. Perfect. This is how we balance all the chemical reactions. And now let's see what are different types of chemical reactions that can occur. Chemical reaction can be classified into multiple categories. The first one is combination. Second is decomposition. Third is single replacement. Fourth is double replacement. This replacement sometimes can also be called as displacement. So single displacement or double displacement or replacement. They are used interchangeably. And the last one is a combustion reaction. If a question sometimes asks you, can you classify the reaction in what type of reaction it is? It is sometimes a reaction can be multiple different kinds. For instance, a certain reaction can be an example of a combination reaction and a combustion reaction at the same time, which is okay. Sometimes certain reactions can be classified into multiple different categories of type of reaction. Okay, now let's see a combustion reaction. Okay. For instance, if I dissociate CuO, I can convert this into Cu. Copper is a metal, oxygen is a non-metal. In this case, oxygen is O2 minus. So copper has to be, if copper is X, X plus minus 2 will give us 0, which means copper is a charge of plus 2. So copper here is changing into copper 2 plus, and that means that if we try to balance this charge change with electrons, if I see copper is changing into copper 2 plus, what you see here, each of these copper atoms has a charge of 2 plus, which means to get a plus charge it has to lose electrons. So this has lost each copper. Instead of writing 2 coppers, if we work with 1 copper atom, copper here has a charge of 0, it's changing into copper 2 plus, and each of this is basically losing 2 electrons. So loss of electron, here the copper has lost electron, so electron is a product. Loss of electron is an example of oxidation. On the other hand, how is this getting oxidized? Copper is reacting with the oxygen in the air to form copper oxide. So the other reactant here is oxygen. Oxygen is O2, so which means this has a charge of 0 here, is changing into oxide. Oxide is O2 minus, like we saw here. So now what is happening here? The charge of 0 is changing into negative, which means there are electrons being added to this oxygen. So each oxygen atom is taking 2 electrons, which would mean a total of 4 electrons are being used, because oxygen gas has 2 atoms of oxygen. So this is addition of electrons, so it's called reduction. So you can take this reaction and break it into 2 halves, where one half is oxidation and the other half is reduction. For this reaction to happen, one compound always has to be oxidized. The one that is being oxidized, the one compound that is present in oxidation reaction is getting oxidized, the other one is getting reduced. So here copper is getting oxidized and oxygen is getting reduced. So you can divide this into 2 half reaction. Therefore it is called oxidation reduction reaction, or sometimes it's also called redox reaction, where RAD comes from reduction and OX comes from oxidation. Okay. Some other examples are right here. You can see copper sulfate reacts with zinc. Copper sulfate here is reacting with zinc and changing to ZnSO4 and copper. One thing you would see here, if you were to identify what type of reaction this is, you would say zinc is taking place of copper here. So this is an example of single replacement, right? But in addition to that, that is correct. In addition to that, this is also an example of oxidation reduction reaction, where copper sulfate is basically Cu2 plus is changing into copper in the reactant, in the product, which is Cu0. So here copper 2 plus is gaining 2 electrons to form copper, whereas zinc has a charge of 0, as you can see. So zinc is a reactant, is changing into ZnSO4. If you break this, it would give you Zn2 plus, which is the product. So zinc here is losing electrons. So basically copper is gaining electron. Gain of electron is reduction. So copper is getting reduced, and zinc here is losing electrons. So zinc is getting oxidized. So you can tell this is also an example of oxidation reduction. So type, if we are asked what type of reaction this is a single displacement or single replacement reaction, and also an oxidation reduction reaction. Okay. That is why I said sometimes certain reactions can also be classified into different types. multiple types of reactions. Okay, for instance, in this case, identify in each of the following reaction as an oxidation or reduction. So if we look at the first reaction, Sn is changing to Sn4 plus 4 electrons. So in this case, what is happening? Sn is losing electron. This is our reactant. Our reactant is losing electrons. Therefore, electrons are a product. Product means you lost it, right? So Sn is losing electron. Loss of electron is oxidation. OIL, OIL, break. Okay. Next reaction that we see is Fe plus 3 gains 1 electron to change to Fe2 plus. So here we see Fe plus 3 is gaining 1 electron. 1 electron is being added to this. You see this plus sign? It's a reactant. It's being added to Fe3 plus and then it changes to Fe2 plus. So Fe3 plus is gaining an electron. Gain of electron is reduction. Gain of electron is coming from ring. Next you see Cl2 is gaining 2 electrons. Again, this is gaining 2 electrons to change Cl minus, which means this is also an example of reduction. Okay, so that's how you can identify if a reaction given to you is oxidation or reduction. Another example question you can see is in light sensitive sunglasses, UV light initiates an oxidation reduction reaction. Ag plus Cl minus is changing to Ag and Cl2. Which reactant is oxidized, which reactant is reduced? One easy way to do this is you divide this reaction into two reactions. One reaction is Ag plus is changing to Ag. How do you divide it? Basically, the atom that is the reactant is going to, you should have the same atom as a product, right? So Ag plus is changing into Ag. And what is the charge on Ag? Ag is 0. So if this is plus charge, this is 0 charge, I need to balance the charge on both sides of the reaction. I have one atom of silver, one atom of silver. Next I balance the charge. What is the charge on this side? It is plus 1. What is the charge on this side? It is 0. Now remember, when you're balancing charges, you can only add electrons. You can never remove electrons. You can never change protons or neutrons. Only thing we can do is we can add electrons. To make this charge equal to 0, if I add electron on the reactant side, the total charge will become plus 1 negative 1 will become 0. So now this reaction is balanced. So in this case, what is happening? Electron is being added. So gain of electron is reduction. So which reactant is getting reduced here? Ag plus is getting reduced. Next, if we try the second, we can also confirm with the second one. If this is Ag plus is getting reduced, which means Cl minus is getting oxidized. So you can simply write that, but we should also confirm again. So we can rewrite this reaction. Cl minus is changing to Cl2. How many Cl minus? We have 2. So number of atom is balanced. What is the charge on Cl minus? It is chloride. It is minus 1. So total charge here is 2 times minus 1, which is minus 2. What is the total charge on the product side? Cl2 has no charge, therefore you don't see a number, so we'll assume it is neutral, so total charge is 0. If the total charge is 0, I need to balance the charges out. If I add another electron on the reactant side, then what would happen? It would increase the negative charge here, which will increase the unbalanced reaction, right? It will add to the unbalanced component of this reaction. So instead, I will add electrons on the other side. If I add 2 electrons on the product side, how many total charge do we have on the reactant? Minus 2. What is the total charge on the product side now? 2 electron brings 2 negative charge with them, so total charge would be 0 plus negative 2, which is negative 2. Now the charge is also balanced. So this is what is happening here. Cl minus is losing the electron. Electrons are a product, so this is loss of electron. Loss of electron is OIL. So this is an example of oxidation. And who is getting oxidized here? Cl minus is getting oxidized. Okay, so those are examples of oxidation reduction reaction. There are some more definitions of oxidation reduction reaction. First we saw was oxidation is loss of electron, reduction is gain of electrons. Sometimes it is very difficult to see the electrons being transferred. So sometimes you could also see, in case of oxidation, oxygen is being added. Oxidation is coming from oxygen. So if something is getting oxidized, addition of oxygen is happening there. Or loss of hydrogen. So oxidation can be loss of electrons, or addition of oxygen, or loss of hydrogen. And reduction will be gain of electrons and loss of oxygen or gain of hydrogen. Exactly opposite of oxidation. How can you memorize this? First, I think you guys should have memorized oil rig, which tells you electrons. Next, oxidation, the name tells you